Early. Can you see them at all?
Yes.
I'm going to turn the computer. Sorry.
Those people are fast.
Can you guys see me now?
You're a little off camera, Dave. Well, let's see the whole.
I intend to be off camera for just a second.
Okay.
Okay, what you're seeing, and I'm sorry you missed the ladies, but they were going home. What you're seeing is 4,500 personal computers connected with 500 servers, also made with personal computers. And they run a factory of 1,600 ladies doing a very complex job of combining chips that don't work for anybody else and repairing chips that don't work for anybody else into DIMM product which go into personal computers. So I thought you might like to see one, what I call an endpoint. Okay? We'll come back, look at myself for a second, then I gotta get my notes up. Are you ready for me to start the presentation? I want you to see the room.
Yes, you are. Yes, you are, Chuck. Everything is set already.
And you can hear me okay?
Yes.
Okay.
Could you put your hat just a little bit back in your head?
No, because it's a stupid headset. Is that better?
Yes, sir. Thank you.
And I need the headset because you guys are having trouble hearing me without it. Here, a second. I'm trying to hat over the headset. Is that better?
Yes.
Can you hear me okay now?
You're awesome.
Okay, hold on a second. Get my notes started here because I don't want to miss. I'm doing a whole lot of people's names that nobody will ever care about except me. But because I don't want to miss them. Okay, welcome to paradise. I'm in a country called Sri Lanka, which is truly, in fact, some people believe it's a paradise that Adam and Eve were thrown out of. The ladies that you saw for a brief second, there's about 1,600 of them. As I said, they run 450 personal computers with 500 loosely coupled servers. We use barcodes and people to design and implement a patent on how you combine chips and how you make die. And they use computers as their workplace, right? Without worrying about programming, without anything else. This is an endpoint. Rockets designed by computers and run by computers. Gaming, all are endpoints. Doing this speech by video and Skype is another endpoint. I want to apologize to everybody who came to the meeting expecting to see my ugly face, other than on camera. I had planned on being in Philadelphia or Pennsylvania during this time, but we had an exciting quarter in our business, which is a memory business, in which the price of our end product fell by 1.5 times. And so I had to come back to the factory and put some things in place to make sure we made a profit this quarter. And I couldn't come. But I thought it would be kind of fun to do it this way anyhow. Can everybody hear me okay?
Yes.
Am I speaking too fast?
No.
Okay. I have to be careful because I'm in a country where people speak English as a second language. And so I try to slow down. But talking to you guys, I'm liable to speed up. I make a comment that we did a PC camera at Commodore in 1979. I wish I remember the guy's name. He was a little strange. But he got the previous technology before CMOS LCD. And he made a video camera and he hooked it up on the computer and he was going to include it in a Commodore product. It was also going to be included in what was called a toy. But he was lost in a jack attack when we got rid of a bunch of people. And it never happened at Commodore. At least I don't think it did. Maybe it happened after we were gone. The whole internet, email, chat are endpoints. We could spend a good part of this hour talking about endpoints. I've given you some examples. I just wanted to show you our little funny factory. But for one time only, I'd like to talk about how we got to where 30 years ago we shipped the first personal computer. If you don't mind, part of it has to do with what was inside my head. And I'd like to kind of explain how it got there. And then we'll pick the people up as we go. All right? I graduated from college at the University of Maine in 1959. In 1959, although this is a major campus graduating thousands of people every year, there was not one computer on the campus. There was, luckily for me, a guy who had worked with Claude Shannon, who's really the inventor of the whole concept of information theory. And he worked with Shannon, and he had a nervous breakdown. Because he had a nervous breakdown, he moved to the University of Maine. They gave him 2 classes a week, and what he taught in that class was information theory for the masses. He spent weeks teaching us about the ear and the eye, because he said all information that goes with human beings have to be communicated through these techniques. What he did was get me totally hooked on the concept of Boolean logic, binary arithmetic, and everything else, to the point that I changed my life. I only interviewed companies that would give me a computer job. I had been in the West with the Marine Corps. I wanted to go West, so I wound up going to work for General Electric Company with the commitment that I would go to their plant in Phoenix. When I first went to Phoenix, hello, can you hear me?
Yes.
Okay.
We're listening.
Okay, well, I thought I heard some feedback that said maybe you could. I'm sorry, I'll just keep going unless you shout at me, all right? Okay. My first job when I went to work for the computer company was building a computer, that's your peripheral, a card reader, building with PC boards that had an AND gate, no, 3 AND gates or 1 flip-flop on a PC board. All made with transistors. We weren't at LSI or anyplace else. Every computer that we were working on at that time had only core memory. I left Phoenix for a while and went to our computer laboratory in Palo Alto, and where I worked on things like cryogenics. We hoped that cryogenics would make fast computers, but it didn't. And I met 3 key people there. I met a guy by the name of Joe Weizenbaum, and I'll explain why Joe's key in a couple minutes. Bill Davidow, who later sold me and a whole bunch of people on the concept of the 8088 when we did our first PC clone, and a guy by the name of Bob Schreiner, who I'll pick up in a minute. When I went back to Phoenix, we started designing a generation of computers that were going to be limited multitasking. To do any kind of multitasking required that we had hard drives. My first hard drive, which I got a chance to work on and design for, was 6 feet tall, 4 feet across, had 5 megabytes of hard drive, and was accessed by pulling a coil on a motor. At that time, we figured out that zone recording would give us a much higher density. And we actually filed a patent on zone recording, which is used in every computer today, or every disk drive today. But the hardware to do it was not possible. With the kind of hardware we had, the logic required to do that just couldn't be done. So literally the patent ran out before the technology for semiconductors caught up to it. I worked in, I moved from doing design into designing computers for other people and doing PC layout. Doing that job, I got my own personal computer. My first personal computer was an NCR 304. It had hardwired macros, and 4 tape drives. My second personal computer was a GE 400, which was one of these multitasking things we started earlier with a real hard drive system. And I got a chance to do a lot of things in the early creation of how you use a hard drive. While I was at GE, they were pioneering communications using computers. One really key guy by the name of Peddle taught the whole company that you could talk over a teletype interface and communicate with a computer anywhere. And because of that, because of what he did, there was a guy at Dartmouth that had a genius that wanted to teach engineers how to use computers in their work. And I can't find his name. If anybody knows it, I'd love to have it. I'm thinking about trying to get Bill and a couple other people to put together a website just honoring that guy, because he was the one that created the concept of BASIC, the concept of using BASIC in a remote way, and he's never got one bit of fame. Okay, I've got one more idea on how to get his name, and if I do, I'll make sure it gets on the Commodore website at least. Okay, anyhow, his idea was he was going to give all the engineers a class, 1 hour. He invented this little language that they could learn in that hour that was kind of algorithmic based, a little bit like alcohol, but was very, very simple to train and use. And what he needed was an online computing system. So we built the first online computing system for him, using some technology we had in place and that Peddle created. And in Dartmouth at that point, then every student was given a 1 hour lecture and access to a teletype. Let me give you an example of what that meant. Some of you probably still fool around with BASIC, and you probably don't use data statements very much except for standards. But you got to remember that the reason he invented the data statement was he had a bunch of people using teletypes and he didn't want to fool around with I/O. So he basically created data statements as the I/O that worked with a teletype and a student. All right? At GE, I taught the first class of BASIC to our engineers, most of whom were programming in other languages, Algol, Fortran, COBOL, and they didn't really care. I went to a very big computer center in Ohio where we were building engines for the DC-10. And they had a massive computer operation, and I was the technology guy for that. And what we discovered is there were a bunch of engineers there using a weighing system that was programmable calculators, but they mostly were programmed in BASIC. And then we built 2 computer centers just for engineers who wrote their own programs to design engines. We also, at that point, set up several computing centers inside the company. And this group that business was very advanced. And so we ran BASIC for all of the other departments. Based on the work we did, GE decided to go live with BASIC and time sharing. And what they were big computers with central databases and online capability, but very slow. And very few monitors. Actually, just mostly building teletypes for monitors. Okay. About the same time, all the universities started making BASIC a requirement for all of the disciplines in the school, so that everybody came out of school trained in BASIC. And because of what GE was doing, they had a chance to use BASIC in their work. This was in the late 60s, right? Early 70s. And during that same time is when there was a revolt against science. Most of you are probably too young to remember it. But we stopped work on the ultrasonic airplanes, we quit doing MO, did a whole lot of things because the people were in the universities and wearing the long beards and so forth were revolting against anything technology, right? We're going to go back to the nature. And one of the things that happened was that they started trashing computer rooms. So most companies literally put walls around their computer rooms and security around their computer room. And so if you wanted to use a computer in a big company, The only way to use a computer is you would make up a deck of cards, you take it down, leave it in a tray, and maybe a day or so later you get your computer. All right? So at the same time, the cost of doing this online, centralized, very expensive system called time sharing basically meant that GE had to charge too much. All the companies took a look at their time sharing bill because everybody was using it, and they stopped time sharing. So students still learn BASIC. They learned how to use it, they learned how to write programs in it, but after they left school, they couldn't use it. When I went back to Phoenix from my job in Ohio, I sat down and we were designing a cash register system. And the cash register system at the time I went there was a very online cash register system. You hit a key, you had to go all the way to a central site, come back and tell you what the key was. There was no local storage, no local intelligence. I'll tell you what happened in a minute. I looked at that and a bunch of other things that kind of been in my head and just developed the concept of distributed intelligence. Changed my life again. I've been working on distributed intelligence ever since. When I was at Phoenix, a guy by the name of Bob Schrainer, you're going to hear his name 2 or 3 more times, all right, took me to Fairchild and showed me what Fairchild could do with custom silicon. So we developed a theory inside the company with me and several other people that we could build intelligent cash registers, we could build intelligent credit verification with the intelligence in the device. And we were going against the established party line, which was said everything is online computing. Well, a funny thing happened. They put pennies online, and they put every cash register in pennies stores in Orange County online as a test case. And somebody ran a car into a telephone pole outside the central processing area. And in every store that Penny's had in Orange County that day, which was the day after Thanksgiving, they could not sell anything. So that was kind of the end of online cash registers, right? Which should have happened. It wouldn't have gone away as fast if we hadn't had that fiasco. But we were right. We were right that distributed intelligence was going to work. One other thing was going on at the same time, and I'm going to try, I really will tie these all together in a couple minutes. At GE, they had developed a pretty fast multitasking system with the ability to do a significant amount of communications. Dr. Joe Weizenbaum, who I met back in the computer lab, had gone to MIT, and he developed a theory that says if I give a programmer total space, right? He doesn't have any limitations in his code, doesn't have any limitation in his data size, I will be able to develop programs that work better, faster. And so he got MIT to fund a program called Project Mac, which, by the way, any of you that have been through MIT, you're still there. It's still Multex. It was revolutionary because what he did was to show he was correct, that with that kind of resource, a programmer could do anything. And the idea was a very expensive online system. It was so expensive, and Multex was relatively complex operating system, that I'm going to forget I had it just a second ago. Guys that work for Bell Telephone, Western Electric, I think it was. Anyhow, at that lab for Bell, these guys took a look and said, this is a great system, but we can't afford to keep using it, it's too expensive. So they took a mini computer from DEC and they wrote a program that was a subset of Multex, which all of you know is Unix. Now the word Unix, if you think about it, doesn't mean multitasking 35 million people using the same computer. These guys actually did intend it to be a simple one-person machine, but of course they put all the stuff over from Multex, which meant they could do multitasking. They also, along the way, invented C. Okay? So what we had was a real proof that giving a programmer or giving individuals enough compute power that belonged to them, that we could do a better product. Okay, I left GE to build cash registers, automated gas pumps, and credit verification systems in 1970. It was a great concept. We actually built a demo unit using as a memory national shift registers because there weren't any memories, right? And I made it work and I showed it to everybody. And they said, well, what can you build it for? And we did some calculation, and without going to silicon, we couldn't do it. So we didn't have the money to go do 6 custom silicon devices, and I had to have a building block. So I went to work for a guy at Motorola who made the 6800 happen. He was a calculator guy. He said, I believe the world needs a microprocessor. And everybody else said, what's a microprocessor? And what he defined it as was kind of a super calculator, but he knew it really shouldn't be. So he said to me, he hired me, saying, look, you already know what you want. Go make it happen. And they gave me a chance to do that. We developed the programmable I/O device, several changes to structure of the 6800 that made it a product that we ultimately sold to a whole lot of people, right? Ultimately, Motorola got to put all their microprocessors into cars and everything else, which was all the work we did. But the problem was that Motorola marketing guys thought what we had built was a replacement for the mini computer. Now, mini computers at that time were going for $700, $800 minimum, and by the time you built them up, they were starting to grow big because of Unix. And so these guys said, well, I've got a $300 mini computer, that's what the world needs. Okay? Now, I did a class at Motorola because nobody else understood microprocessors except me. Sorry to say, I was trying to brag about it, just literally everybody that was in designing microprocessors at that time, Intel, every place else, came from a calculator background, didn't understand what you did with a microprocessor. So I did a class for the application guys, and in the class, the guy was on sabbatical from our state by the name of Roger Camp. Dr. Roger Camp helped me change the world, and you're going to see how as we go through this thing. Right? When I had to go out and do all the applications support for Motorola, because again, I understood what they did. So when I would meet with customers, we'd go through this discussion about the 6800 and how wonderful, and they'd fall in love with their I/O devices, and then they would say, but your processor's too expensive. So what I would do is I would sit down at a blackboard, and we would write down the minimum instruction set, and they wanted a $25 microprocessor. Well, Motorola marketing guys found out I was doing it, and they got Motorola to give me a memo that says stop. And I wrote them back a memo that says, guys, the minute you told me to stop, you gave me the rights to everything I've worked on. I don't care what your patent agreement with me says. When you abandon a product, it belongs to me. Okay. All right? Just cut. Turn my video off again. I'm not doing anything obscene while I don't have my video on, am I?
No, you're looking good.
Okay. I've got the bunches notes, and I said I want to get all these names because they really are people who made major contributions, most of whom were totally ignored. Okay? Anyhow, just...
You ended right about talking about 6800?
No, I'm going to talk about what we were doing next. They threw me out of Motorola, basically, right? Been thrown out of a lot of better places. Through a series of flukes, I discovered that the engineer who did the very first magnetic ink character recognition system, who I worked for at GE for a little while, was now doing high-end calculators, semiconductors in Pennsylvania. And I talked to 2 or 3 other semiconductor companies. I had to have a semiconductor company that was going to go do this, and most of them were afraid of Motorola. But when I explained to him, as a computer guy, when I told him what I wanted to do and how I wanted to do it and why it made sense, he understood it. His name was John Pavenin, And he made almost everything that we're going to talk about afterwards possible because he backed us, right? And he ultimately got sued by Motorola, cost him his company. But he understood and he backed me. We took a design team from Motorola and moved to Pennsylvania. If you mind, I'm going to tell you the guys' names because, again, only one of them stayed famous. Bill Minch, who is the head of the Western Design Center, who did the 816 for Apple, who did the 816 for all of the video games, is still the guru of 6502. And, you know, he kept it going when the rest of us walked away. So, more power to him, and I'm working with him now on a new design, actually. A guy named Ron Argill, who was one of the key designers of the 6800, did the architecture with that, decided he'd rather live in the West than Pennsylvania, took off, and we've never heard from him again. Another guy by the name of Ray Herd, who was more of a process guy, went back to Arizona working for another company. A guy by the name of Will Mathis, who had joined us at Motorola and who was an alternate architecture. He actually designed the controller for the bank systems where you could put your money in and it would give you credit, you know, the beginning of the automated teller system. And Will and I were the two that did the logic for the 6800, and Bill and the other guys did the circuit design and the internal architecture. Will wound up working for DEC, and then I think he just went back to Pennsylvania, and I have not heard from him since. If he was in the audience today, I'd love to hear from him again. One of my favorite people at one time. We had two layout guys, a guy named Harry Bauckham, who was a little crazy, not a little crazy, a lot of crazy, and a guy named Mike James, who cost us a lot of trouble, but was a really good layout guy. Took apart this guy, Terry Holt, and John Pavin, and John developed a new 5-volt process in the same amount of time it took to develop a microprocessor. Nowadays, if you ask somebody to design a new process, they talk about $500 million and 5 million people. John and Terry did it effectively by themselves with a couple other people. We did the 6502, the VIA, and the combo chip in 9 months. One of the things about Bill Minch is he's never built a chip that didn't work the first time. Just a phenomenal guy when it comes to getting a layout to work. There's some wonderful pictures, which I couldn't get my hands on to ship around, of what we had to do the layout. It actually drew these pictures on walls. We had one entire room with 6502 on it. No simulation. None of this wonderful layout tools you have today, all in my hand. Okay? Because we knew what people wanted in a cheap micro, but also the tools, we developed a cross-compiler with a guy by the name of Mike Porter, who was my first contact from Dr. Roger Camp. Mike did the cross-compiler for us, and then later on did a lot of wonderful things with me at my follow-on companies. We got an online system, online simulation system called TM1 with some people in California. And based on a very creative idea, because they were calculator guys, by Don McLaughlin, who was the engineering manager, and Bob Wilderhalter, who was the programming manager, it was their idea that created the KIM-1. The KIM-1 became almost like a standard for people who wanted to learn about microprocessors. You really couldn't do much with it, but it really and truly was an introductory product. It was on one board, you could buy it, it worked, it was a wonderful idea. More power to those guys, and you probably never even heard their names, but now you heard them. It's their idea, it wasn't mine. We carried it forward, but it was done by that team, which was part of the team at MS Technology when we joined it. We introduced the 6502 at a component show in San Francisco, and we'd taken an advertisement in the paper about 2 weeks before, saying, come to this show, we'll sell you a microprocessor for $25. I remember that number came out of those all research we'd done, and we wanted to sell, we could sell one for 25 because we wanted to apply, which we ultimately did, we could sell it a lot cheaper. But the most important idea was we had it. We weren't just talking about futures. We had it. You could come by the show and buy it. 2 days before the show opened, the show guys caught on to what we were trying to do and said, no, you can't do this. You're not allowed to sell anything on the floor. You're bad guys. What are you trying to do? Ruin our show? And so we said, okay. So we took a suite at the St. Francis Hotel, called the MacArthur Suite. And if you went by our booth at the show, we said, take the bus over to the MacArthur Suite. Well, there were so many people packed around our booth that wanted to go to the show that ultimately people would get on the bus and says, is this the bus to the MacArthur Suite? These people would came in, we laid this room up really nice. You could see the Kim 1, you could see our layout, you could see the Tim, all this sort of thing. There are 2 books that were there, and I'm going to tell you a little story about how we wrote the books, that were really quite well received, were there. And sitting at the table was my beautiful wife with a barrel full of microprocessors. And if you were to buy a microprocessor, she'd reach in a barrel and sell you one for 25 bucks, and then you could buy 10 bucks each for the books that we had. And you could buy a Kim 1, we had some Kim 1s for sale. Ultimately, only a few sold that day, a whole bunch sold right after that. And the story about the barrel was the top 10% of the barrel had working microprocessors in it. The rest didn't work. Really impressive. Okay, there we go, barrel of microprocessors. We had a very famous guy come by and buy something out of the barrel. The guy's name was Steve Jobs. He took his processor back to Woz and they created Apple. A side story, and I'm going to tell you about this guy in a second because he's a really important guy along the way. My West Coast manager talked to the Apple guys who were having trouble bringing the original Apple I up. I had this development system that weighed 550 pounds. They used to carry around, and it had a little teletype printer hooked to it. And we took it out to the garage, and we hooked it up, and we showed them what they were doing wrong, how to develop the program. So actually, Peter and I helped bring up the Apple I. We will never get credit for that. And nor do we really want one, but it was because they were just another customer. Right after this show, if you don't mind, I'm going to deviate. I was just going to do something else next, but I'm going to deviate for a second. Remember I told you about these 2 books? Well, I had a guy work for me in Phoenix who had escaped from Czechoslovakia. And he was brilliant. You know, matter of fact, I had 4 Czechoslovakians that were brilliant, that all escaped from Czechoslovakia. And Peter and I formed a lifetime relationship. Peter was working for somebody else. I talked to him about joining us at MOS Technology to help me be my West Coast guy because he was very skilled about computers, good application guy, a very pleasant guy, and knew how to sell because he'd actually worked for, I think it was Peddle at the time. Peter was brought back to help us write these books, and he started writing the books with me, and I had to write a lot of it. And I was busy. I was doing the marketing, I was helping finish the engineering and everything else. So Peter went to John Payman one day and said, if you don't throw Chuck out of the building and make him stay home until we finish these books, we're not going to have the books done on time. So John, being the wonderful person he was, he called me in his office. He said, I've told the guards you're not allowed in the building. Go home and write the damn books. Well, thanks to Peter, the books were very well received, and I did stay home and write them because John meant it. He wouldn't let me in his building. Nice story. Peter was the guy that actually supported Apple, and another very famous customer. When I was developing, when we had announced the C502 was in the paper and everything, but we hadn't actually done the show yet, we started getting all these people sending emails and making phone calls, and I would look through the list and say, well, now we're going to bother call us back, we'll see who's at the show. And there was this one from a place called Grass Valley, California. Those of you that know California know it's a beautiful, wonderful place, but it's not the sort of place you expect to have a high-tech question coming from. So I got on the phone with the guy and discovered that that was the research park for Atari. So right after the show, we went up to Grass Valley, we met with these guys, and out of that came the decision that ultimately created the programmable game. Because he could see, this guy could see that with the microprocessor and the combo chip, he only needed one more chip to make the programmable game. Now, just before the show, we had brought on a company called Centertech, and this is the final tie to my buddy Bob Schreiner. Schreiner had left Fairchild along with all of the other people at Fairchild and started Intel and all these other things, and he wanted to start his own semiconductor company, so he got Honeywell to invest in him, and he started a semiconductor company, but he was doing kind of mediocre. But he knew me and John real well, and so we went to him and said, look, we need a second source before we introduce, because Motorola didn't have a second source and Intel didn't have a second source, and we wanted to be second source so people would use our product. So Schreiner said, yeah, sure, I'll be happy to do that. Well, it turns out it was very important to him because Atari said, we don't want to get caught up with an East Coast company doing development. They took two guys, one of whom, Jay, went on to do the, come on, all of you know the name of it, somebody help me. Follow-on product that Jack Tramiel sold. I mean the Commodore sold.
Amiga?
The Amiga, thank you. Jay's name's hard enough, Amiga, right? Anyhow, Jay sat down and did the design for the chip for Atari. And the combination of 3 chips, we introduced the thing. 1 week after Atari introduced our product, Motorola sued us because they were mad. Anyhow, Schreiner designed the video chip. We provided them with micro and a combo chip and created the programmable game market. All right. At this point, we're at MS Technology. We have a great future because, you know, Atari's coming down the road. But the company was having trouble because this is a period of time when calculators started to die in the United States because the Japanese had brought in CMOS calculators. And the guys at MS Technology basically said, look, we can't really fund the bridge. So we're going to start selling Kim-1s, which we did, which helped from a cash standpoint. But I had to go out on the road and start designing customer applications that would come in faster than Atari. Well, 2 of the places that I went to, one place in Florida, and had 2 key things happen there. One, I was designing a copier, which was fun. I did that in about a week and a half. And then I was sitting at this place in Hialeah, working around the clock, designing an electronic pinball game, which was, again, a lot of fun. We did finish it, we put in shows, everybody thought it was wonderful. And ultimately, of course, all pinball games use microprocessors. Well, in the company, there was a guy who had been a musician, followed the music guys around. He wasn't a musician. He was a guy that went and did the sound stuff, and he had this long ponytail, and he wore shorts all the time. And he was getting busted all the time because he was a blue boxer. Okay, so he got busted for being a blue box, he got busted because he looked like a hippie. But he was really good at sound. So these guys had them sitting in his company designing the sounds for these games, which again, if any of you are old enough, you'd recall that if you went to an arcade, you were really dealing with electromechanical device that made noise more often than you were dealing with video stuff. So that's what he did. Well, so he would work at night, and I'm going to deviate for just a second. The last thing I did on my way back from the announcing the 65-2 was stop in Colorado with a company called, the guy's name I remember is Dr. Sitting. I don't really remember the name of the company. And what he was